In our test series, in this problem, two charged particles having same kinetic energy are allowed to pass through a uniform magnetic field perpendicular to the direction of motion. If the ratio of radii of their circular paths is 6 east 5 and their respective charges ratio is 1 is to 2, then ratio of their masses. Options also are there, and try to solve this problem. Here, so given concept here, we'll see the concept first. The the uniform magnetic field, through uniform magnetic field, the charged particles are projected perpendicular to that. Say v1 is the charge particle velocity of first charge, and v2 let us take second one. So when you take magnetic field, say into the paper, normal to the paper, and now charge particle is projected with velocity v1, then sorry it experiences a force perpendicular to the field, perpendicular to the both the things. That is, the force acting is normal to the direction of velocity. That is, force acting will be maximum. Okay, so F max is BQV. If Q1 charge is projected, B Q1 V1, and this maximum, this force tries to rotate the particle in circular paths. When particle is rotating or particle is moving in a circular track, the centrifugal force acts on it. That centrifugal force is mv square by r. Okay, the radius of the path is r1. It should be equal to the maximum because they are balanced each other. So finally from here, the first charge has mass m1. Let us write here. Go to the next line. And velocity we can cancel here. Say relation is m1, v1 is equal to b q1 r1. Similarly, m2 v2 is equal to b q2 r2. So in this problem, one condition is given: kinetic energies are same. The kinetic energies of two charged particles is same. That is, of m1 v1 square is equal to of m2 v2 square. Of we can cancel both sides. So here v1 square velocities ratio we got v1 square by v2 square is equal to m2 by m1. Okay, so take the ratio of these two equations, m1 v1 by q1, and you will get relation. And here one more relation is there, and using that solve this problem. Data given in this, what are the charge ratios given as 1 is to 2, and circular paths, the radii given as r is 6 is to 5. Clear? So do it. And option, so answer should be 9 is 25. You have to get B. Final answer is 9 is 25. This answer you should get. So in
Check
our
it.
test series problems, another problem is, so here the electric field through an area of 2 meters square varies with time as shown in the graph. The greatest displacement current through the area is. So here displacement current concept, if you see the formula for displacement current, IED is equal to epsilon naught into d by d phi by dt. Okay, so here in terms of electric field, if you write, this is equal to epsilon naught area, we can write, I would say, area into dE by dt. Okay, so this is the electric field stored between the plates of the capacitor, and you have to find out at what time the displacement current is maximum through the in the circuit or through the capacitor. So very important thing is, see in the graph, the dE by dt, the graph is drawn between electric field and time. Okay, so the slope you have to find out. Simple, easiest question. And what is the slope of this curve? You just divide the curve, divide the curve into different cases. Okay, and this is find out the slope here, and also see here it is, let us think, dividing with number with the multiple of 2, then there should be some 6. Okay, don't worry about this 13. Anyhow, this is for calculate the slope here between this 0 point and 5. What is the slope? There the slope is, I write as s1 x2 minus x1, that is 1 minus 0 0.5, 0 0.5 only, divided by 2, 2 minus 0. So this is 1 by 4. Why we are calculating slope is, see this ID maximum they are asking, ID max, and is proportional to slope. dE by dt is the slope. Okay. And in the first case, the slope we got 1 by 4. And what is the slope of this part? You can take tan theta concept. That is the slope. No? And here's a 6. This is 1, 0, 1 by 6. Okay. Or up to here only you take. Between 2 to 6, let us take. Between already 0 0.022 seconds we calculated. We have to calculate from here to here. That is 1, this is 1 minus, this is 0, 1, and this is 6 minus 2, 4. And here it is again 1 by 4. 1 by, this is 4. And here 0 0.5 by 2. And this part also. In this case also, what will you get? This is 4, 10 minus 6, 4. And this value minus 1, 0 minus 1. Again, this is also 1 by 4. And let us calculate slope of this curve between 10 seconds to 13 seconds. And what is the value here? Minus 1 and 0. That is 1 divided by, what is the time? 13 minus 10, 3. And here the last case, let us 1, 2, 3, 4. This is fifth curve. Fifth curve has slope 1 by 3. So this is the highest slope among remaining. One is 1 by 4, this is also 1 by 4, this is 1 by 4, this is 1 by 3. Therefore, ID maximum is present between 10 to 13 seconds. Now, because there the slope we got maximum comparative to other. Okay, so according to the option, if you check, answer is 12 seconds. Okay, very simple, easiest concepts are there once you understand the concept of displacement current and formula. And this is the formula you have for displacement current. And there in the displacement current, area is the area of the capacitor plate, that if capacitor plates cases are given. Okay, we'll see another similar problem. So let us see based on the displacement current another problem just for your practice. See here a graph is given between electric field in and time. The units are given in the bracket, check it. Million volt per meter, mega 10 power 6 volt per meter. With time is given in microseconds. Micro is 1 micro equal to 10 power minus 6. So that you remember here 1 m equal to 10 power 6, 1 micro 10 power minus 6. Okay. So see that, and you have to calculate A and B between 0 to 4 seconds, microseconds. And here the displacement current through 1 milli a 1 meter square region. See, this one is 1 meter square area. This one, okay. And here also same 1 meter square area is given as 1 meter square perpendicular to the field during the time interval 0 to 4 microsecond and also 4 to 8 separately. And I gave answer also. And solve this problem as I said in previous problem. Find out slope and uh, check your outcome with the answer I gave here. If you did not get, just comment in, to this video. I will answer it.